Our next topic is automatic protocol tunneling, or APT. The things we'll talk about: what an APT master and slave does for the mesh. We'll talk about a description of the configuration and a basic network layout. The basic principles and benefits of APT. The APT master is responsible for all of the encapsulation and decapsulation of Instamesh packets on the wire. The APT function allows breadcrumbs to use available Ethernet links as high-speed mesh links. This eliminates any single point of failure at the mesh to Ethernet connection. If the APT master fails for any reason, an APT slave will take over as the new master. The failover happens automatically without any interaction from the network administrator. Any packet that comes in from the mesh will hit an APT slave and go straight to the master. The APT master will decide if that packet needs to be decapsulated and go to the LAN, or needs to go back out into the mesh via one of the other APT slaves. This is very beneficial for large networks where multiple connections to the wired network are available. This allows the breadcrumbs to aggregate and load balance. The master APT breadcrumb is responsible for all the packets on the wired side of the LAN, going to and from the mesh. So any packet from the LAN destined for the mesh first goes to the APT master. The APT master will encapsulate that packet and then send it out via one of the APT slaves into the mesh. The APT master is also responsible for decapsulating Instamesh packets destined for the LAN. So, as a packet comes in from the mesh, it comes through the slave into the master. The master will then decapsulate that packet and send it to the LAN. Now, this is not to be confused by a normal 802.11 wireless packet. An 802.11 client packet will be encapsulated by the very first breadcrumb it hits, and then that packet will be distributed throughout the mesh. If it's destined for the LAN, it will hit the APT master. The APT master is the breadcrumb with the highest APT priority setting. This setting is available in the Instamesh portion of the configuration table. Every breadcrumb from the factory has an APT priority of 100. So all APT nodes should have an APT priority higher than 100. The APT master is the node that has the highest priority. This is the node that should be directly connected to the layer 3 router or the core switch. If your network has a slipstream, the slipstream should have the highest APT priority. Your other breadcrumbs in the APT network, that is, all other breadcrumbs directly physically connected to the LAN, would be APT slaves. Their priority should be decided as by which breadcrumb you would like to have take over as master should the APT master fail for any reason. Breadcrumbs detect each other by sending out IPv6 multicast. APT links are IPv6 UDP streams. So for APT to work properly, networks should have IPv6 enabled. So any of your VLAN trunks should also have IPv6 enabled. If your edge switches are layer 2 edge switches, you simply don't disable IPv6. Any switches on the LAN with breadcrumbs directly connected should be IPv6 capable. Breadcrumbs will periodically send APT ARPs as well as keep alive packets. A breadcrumb will send an APT keep alive packet to each APT peer if no other data has been sent to that peer since the last keep alive interval. The APT timeout is the time an APT peer will wait before it terminates a connection. If APT timeout occurs and nobody's heard from the APT master, it will be assumed that the APT master is gone and the APT slave with the next highest priority will take over as master. This is what we call failover. MAC flapping or host flapping occurs when two packets with the same MAC address come in to a breadcrumb via both the wired and wireless interfaces as inputs. This is never a normal occurrence. This is always a sign of a network infrastructure problem. The only time that this is allowable is during failover. Periodically, if an APT master reboots or shuts down and failover occurs, it is sometimes normal for there to be a period of MAC flapping or host flapping. This is simply a redirection of packets moving to the new APT master. It should not be prolonged. It should correct itself within about 10 seconds. Rajant's APT protocol prevents host flapping or MAC flapping. It is Rajant's own version of spanning tree. APT is designed to work with spanning tree, however, does not require spanning tree. Your APT timeouts can be set consistent with either a normal spanning tree, which would be a timeout of 45 seconds, or rapid spanning tree, which is normally 8 seconds. Now, if the network administrator chooses not to use spanning tree on the VLANs occupied by breadcrumbs, failover can actually happen in a sub-second fashion. In summary, automatic protocol tunneling allows for multiple ingress into the wired LAN for a large-scale wireless mesh network. Again, this allows for no single point of failure. It allows you to aggregate throughput from your wireless mesh into your LAN. While Rajant does not require a controller for mesh routing, the APT master is like the traffic cop on the wired side of the mesh. He acts kind of like a spanning tree hub and thus prevents your MAC flapping and host flapping phenomena. There will be a short quiz at the end of this module. Good luck.